In 1969, Dr. Donald Goodwin gathered a group of study participants and asked them to each recall the object he had shown them 2 minutes prior. The twist, all the participants were very intoxicated. Despite this, most could pay attention to the task and correctly name the toy they have just seen. Yet, when Donald asked them to recall the object a mere 30 minutes later, half the participants drew a blank, having blacked out the earlier moment entirely. This study illustrates a strange and somewhat selective effect alcohol has on the brain. Many intoxicated people can perform complex tasks like holding a detailed conversation and navigating walk home. Yet, for those experiencing what is known as a blackout, the memory of these events is quickly forgotten. So how does alcohol cause these memory lapses? First, let's identify the culprit. While a single drink often contains hundreds of different chemical compounds, ethanol is responsible for alcohol's effect on the brain. Ethanol is a lightweight and lipophilic, meaning its structure easily dissolves into fats, like those in the membrane of the outer blood-brain barrier. Once inside the brain, ethanol's unique structure is allowed it to bind to, interact, and affect many different neural receptors, impairing pathways that allow you to be careful decisions, control your impulses, and even manage your motor skill. And networks that control memory seem to be especially sensitive to alcohol's effect. Typically, information about your surroundings is taken in by your sensory organs and sent to the brain. Neurons transfer this information to one another via chemical messengers called neurotransmitters, which are released by one neuron and received by receptor another. When a neurotransmitter binds to a receptor, it unlocks an internal channel, allowing small ions to flow into the cells. If enough ion enters the cells, the neuron fires, sending the signal forward. Through this process, different regions of the brain can communicate with one another in milliseconds, creating a moment-to-moment understanding of the world. But the ethanol interacts with the receptors, making it harder for a neuron to communicate. While compromised, the brain is still able to transfer information, which is why many intoxicated people seem somewhat capable of performing basic tasks. In other words, brain function is highly impaired, but not completely broken. But memory storage is a different story. The transfer of moment-to-moment understanding is something we can remember. It's thought to depend on a process called long-term potentiation, or ATP. ATP happens throughout the brain, but it's especially important in learning and memory regions, but neocortex or hippocampus. During ATP, the firing of the neuron triggers a physical change to its structure. For example, more receptors may be moved to a cell's surface, making the neuron more sensitive to future signaling from its neighbors. These physical changes increase the likelihood that cell will fire again at that connection, strengthening the binding between neurons. And through these stronger connections, it's thought that stable memory is formed. Yet studies suggest that ethanol has a unique ability to disrupt ATP. Blocking the physical changes needed for memory information. So while moment-to-moment information is encoded and understood, the storage of the information is blunted, resulting in a blackout. Of course, not all levels of drinking result in blackout. They happen when concentration of alcohol in the blood, or BAC, exceeds a certain level, approximately 0.16. But there's no magic number. A slightly lower BAC burnout or spotty memory of the events can occur, as some neurons continue to function properly while others fail, and drinking too much can cause a person to pass out altogether. Other factors like dehydration level, genetic differences, medication, even how much you've eaten can affect the likelihood of blackout, and teenagers appear to be especially vulnerable due to substantial changes in the brain development during those years. Alcohol's short-term effects usually don't last longer than the time. Alcohol's short-term effects usually don't last longer than the time it takes for the body to metabolize it, or about a day. but repeatedly overdrinking can damage neurons and permanently impair memory. It can also harm the organs like the liver, which works over time breaking down alcohol. After all, experiencing blackout or witnessing others in a compromising state can be a lot for your mind and body to process.